Today we will discuss about normal distribution, the definition and the graphical representation of a normal distribution. Now, before moving on to the technical definition of normal distribution, let's have a look at why normal distribution is so important in today's world when we come to data analytics. So, in order to have mathematical distribution suitable for dealing with quantities whose magnitude is continuously variable, a continuous distribution is needed. The normal distribution is also known as normal probability distribution, and it has happened to be the most useful theoretical distribution for continuous variables. Many statistical data concerning business and economic problems are displayed in the form of normal distribution. In fact, normal distribution is the cornerstone of modern statistics. Now, let's have a look at some facts regarding normal distribution. So, the normal distribution was first described by Abraham de Moivre as the limiting form of the binomial model in 1733. Normal distribution was rediscovered by Gauss in 1809 and Laplace in 1812. Both Gauss and Laplace were led to the distribution by their work on the theory of errors of observations arising in physical measuring processes, particularly in astronomy. Throughout the 18th and 19th centuries, various efforts were made to establish the normal model as the underlying law ruling all continuous random variables, thus the name normal. Now, these efforts failed because of false premises. The normal model has nevertheless become the most important probability model in the statistical analysis. Now, let's move on to the definition of a normal distribution. A continuous random variable x is said to follow normal distribution with parameters mu and sigma square if its PDF, that is the probability density function, is given by f of x is equal to 1 by sigma root 2 pi e raised to minus x minus mu divided by 2 sigma square, where x is the value of continuous random variable, x takes the values of a continuous random variable, mu is the mean of the normal random variable, e is a mathematical constant, and pi is also a mathematical constant. Hope you all know about this. Now let's have a look at the graph of a normal distribution. Now, the normal distribution is a bell-shaped and symmetrical in its appearances depending upon the mu and sigma. The mean of the normal distribution lies at the center of the normal curve. The height of the normal curve is at its maximum at the mean, and hence mean, median and mode for the distribution are equal. So somewhere over here, so as you can see, this is the graph of normal distribution. It is bell shaped and it is symmetrical, and here is the maximum point where you get the mean, and here is the point where the mean, median and mode of this particular distribution coincide, and since it coincides, we say that they are all the three are equal for a normal distribution. And yeah, and if you notice, the two tails of a normal distribution extend infinitely and it never touches the horizontal line. So this also should be kept in mind. That means this is an asymptotic tail. I hope you understood the graphical representation of the normal distribution and also about the definition of a normal distribution. Regarding the other properties like the mean, standard deviation, skewness, kurtosis, we will discuss that in another video. Thank you.